Hello everyone. In this video we are going to cover the lessons in week 3 of the course. If you open the course schedule and you see week 3, still in the Python for Data Analytics unit, we're going to talk about Jupyter Notebook, Markdown, and LaTeX, and plotting with Matplotlib. So let's get started with L3-1. Now I'm going to open L3-1 from this link as well as from my local Jupyter Notebook server, because we're going to talk today in detail about what is Jupyter Notebook, how do we use it, what is Notebook Viewer, what is the difference between edit and view mode. So on my machine, localhost, local server, port 8888, I have a Jupyter Notebook server running in a directory called website that contains a folder called CPTS215. I will show you. CPTS215. And I click on my lesson subfolder. And in this folder, I have a .ipynb file, an IPython notebook file called L3-1. This is the lesson on how to use Jupyter Notebook in Jupyter Notebook. Okay, so this should be somewhat familiar, at least this sequence of opening up the file, because I did this last week in week 2. Now I want to go into more detail about what is Jupyter Notebook, what does it mean for this class, and how do we use it. So go ahead and open up Anaconda Navigator, just like you did during the first week of the course. And you will see a program in Anaconda Navigator called Jupyter Notebook. Now you can launch Jupyter Notebook from Anaconda Navigator in this manner. So I click launch, then a local server on my machine will be spun up, and it is a Jupyter Notebook server. It's going to start pointed to, I believe, my C drive or my users folder. Okay, so my users folder, and with all of my directory listing here. So if I navigate to a folder that contains a .ipynb file, then I can open it in Jupyter Notebook this way. So for example, let's say we're back on the course schedule, and we go to L3-1. I right click, I save link as. I save this .ipynb file and say in downloads. And then in my Jupyter Notebook, I navigate to my downloads folder. And I open L3-1. Okay, this is a copy that I just downloaded. I could run that notebook on my machine, which means any of the code in there I can execute the Python code, and I can edit the text, which I can't do when I view it in Notebook Viewer. So this is a way that you can download all of the IPynb files, the Jupyter Notebook files that I have lessons in, the micro assignments in, the programming assignments in. Interesting, error. That I have my notes in, and you can run them on your own machine as well. In this class, you're not only going to be running some of my Jupyter notebooks, but you'll be writing your own as well. So I'm going to kill this Jupyter notebook because I already have one running. And I'm going to show you another way that I usually launch my Jupyter notebooks is I navigate to the directory I want to work in, my current working directory, such as Computer Science 215. I type CMD, So I launch a Jupyter Notebook in this current working directory. Or you can just open a general command prompt or terminal, navigate to the folder where you want to launch your Jupyter Notebook, and then you can just type Jupyter Notebook because Jupyter Notebook is in the Anaconda 3 scripts Python folder. So this is going to spin up another Jupyter Notebook, but I'm going to kill it. I already have one running. But this is just an example of another way to launch it. So I'm going to close Anaconda Navigator. I'm going to close this Jupyter Notebook server. Okay. So there are two ways about how you can launch Jupyter Notebooks. So what does this mean? Notebook Viewer versus local server. So on Notebook Viewer is rendering an IPython notebook file that is hosted on GitHub. So if I click here for the little kitty, it'll bring me to GitHub, and I can see here's L3-1 to IPYNB. It's just a file that is hosted on my GitHub. Now, when I open notebookviewer.jupyter.org and I redirect it to that file's path on GitHub in my Computer Science 215 repository, Notebook Viewer will render that Jupyter Notebook in this nice website HTML style. It's very nice. I like it a lot. It's very nice. But this isn't editable. If I try to edit any of this text, I can't. If there was code here that I tried to run, such as this code cell here, I can't run this. This is all static. I can't change it. So when I'm actually going to edit this, I need to do so locally on my machine. An analogy that you could think of for this is perhaps when you're working on your resume in a Word document, you're in edit mode, but you can still view the output. But when you're done, you make it into a PDF, and that PDF is uneditable, and it's kind of a finalized, nicely typeset version of your resume. So in the example here, the PDF would be the Notebook Viewer rendering of a Jupyter Notebook, and running the Jupyter Notebook on your machine locally in edit mode is like being able to add content and change the code or change the text in Microsoft Word. Okay, so without any more delay, let's talk about how do we use Jupyter Notebook. So every Jupyter Notebook is a composition of different types of cells, and these cells are arranged to tell a story. Perhaps in this Jupyter Notebook, my story I'm telling with Jupyter Notebook is how to use Jupyter Notebook. But in data science, a lot of data scientists are using Jupyter Notebooks to tell a story about data. So you might start off with describing your problem and then describing your data set, then actually having code to read in that data set and maybe look at the first couple lines in perhaps the CSV file of your data set. And then you might have a proposal for an algorithm that you might want to implement to iterate over your data and compute some kind of interesting statistic or a plot. Well, you can write that code right after you describe the pseudocode of the algorithm and maybe code up the math behind the algorithm in a nicely typeset equation. And then after the code, in line with your Jupyter Notebook document, you can have the results and you can have a plot. And this is all runnable and it's editable, and it tells a nice flowing story of getting from problem to results and solution. So I recommend that you read through all of the text in this lesson, but I'm going to mostly just jump around and show you the important parts and then show you actually how you can work with Jupyter Notebooks. So notebooks in Computer Science 215, we're going to learn about them so you can run my notebooks rather than just view them. So you can create your own notebooks for assignments. In fact, micro assignment number 2 this week does require you to make your own Jupyter Notebook. And also because Jupyter Notebooks are popular in the data science community, I already alluded to storytelling with data, but there's a really great post you can read about from a data scientist who talks about why Jupyter Notebook is a great resource for doing this storytelling. And also big companies like Google, Microsoft, and IBM use Jupyter Notebook, so knowing this is going to make you more marketable. And you can also upload all of your Jupyter Notebooks to GitHub and render them beautifully in Notebook Viewer, and you don't have to write any of that HTML. Okay, so I've showed you how to start the notebook server, showed you how to open notebooks. Definitely do the user interface tour. This will help you get acquainted with all the different parts of Jupyter Notebook. Now I'm going to dive into the cells. So there are 4 types of cells: code cells, markdown cells, raw cells, and heading cells. We won't work so much with raw cells. Heading cells are really just markdown cells that they only contain a header. So we'll work mostly with 1 and 2, code cells and markdown cells. So let's take a look at a markdown cell. I'm going to double click this cell right here. It's a rather large cell, but that's okay. I'm going to double click this cell. You can see this cell is highlighted, this blue line here. And now I am in edit mode for this cell. Now, we're going to learn about Markdown in the next lesson, but this text is typeset using a language called Markdown. It's like HTML, but much easier to use. So for example, a header in Markdown, a section header, is denoted by a pound sign, and the number of pound signs denotes the section level header. So opening notebooks is a 3rd level header. And if I render this, then you can see this text is smaller than, say, this text, which is a 1st level header. Okay, so code cells look like this. If I double click them, the blue turns to green. Now this is in edit mode, and I can run this code using Control Enter as many times as I want. I can change this code, so maybe instead of asterisks in between all of my items, maybe I'll have smiley faces. Control Enter will run the code cell in place. Shift Enter will run the code and move me on to the next cell. So I've already touched on the different cell modes. Edit mode, you can modify the contents of a cell. Command mode is where you actually view the cell. So right now, all these cells are in view mode. The blue denotes view. Double click and that will bring you into edit mode. I highly recommend you read this section here on workflow and learn some of the basic keyboard shortcuts for working with Jupyter Notebooks. It will save you a lot of time if you can just enter the keyboard shortcuts rather than come up and have to deal with the toolbar or the menu bar. The most common ones that I use are listed here: Shift Enter, Control Enter, Alt Enter, Escape and Enter. Escape is how you get out of edit mode. Enter is how you get into edit mode. Insert a cell above, insert a cell below, convert cell to markdown, convert cell to code cell, and delete a cell. I use these all the time, and there are many more, and you can find that out by clicking Help and keyboard shortcuts here. They're all listed out. But these are the most common ones I think that you must know in order to save time when writing Jupyter Notebooks. And one of the last thing to note in this lesson is about Spellcheck. So by default, there is no Spellcheck in Jupyter Notebook, which is really a shame because we need Spellcheck. I make typos all the time. I rely on Spellcheck in order to catch those. So if you go to this site here, you can download a little plugin that will add Spellcheck. So for example, this button here is a result of the extension that I installed from that link, and if I click it, then I can turn on Spellcheck, and you can see Jupyter and Toolbar and CPTS and 215 are supposedly spelled wrong. This is really important for this class. I cannot emphasize enough how important Spellcheck is, especially since you will be writing micro assignments and programming assignments in Jupyter Notebook, you want to have that spell check feature so that you're turning in code, you're turning in Markdown that is really beautifully written and it is free of typos. So definitely download the spell check. So let's move on to talk more about Markdown, specifically how we can use Markdown in Markdown cells and what is LaTeX. So now I'm going to move on to L3-2. Markdown in LaTeX. Okay. So an overview of Markdown. Markdown is a simpler version of HTML. And HTML is a markup language used to create websites or web pages. I'm sure many of you are familiar with some HTML, perhaps from a class you took in high school. So, for example, here is a little snippet of HTML. So there are tags, which are noted by angle brackets. So a starting tag like h1 and an ending tag has /h1. So this is for a level 1 section header in HTML. And in between these two tags is actually the text that is going to be a section level 1 header. So in Markdown, instead of having to write out all these tags, instead we can just specify a section level 1 header with a pound sign, a single pound sign. This is the Markdown equivalent of this line here. Now, you don't need to know very much HTML in order to write Markdown, but knowing HTML is really useful for computer science and for data analytics. There's a really great tutorial here that you can follow along. It takes less than an hour to build a very nice website to learn about HTML and CSS. Not required for the course, but recommended for your degree program, no matter what degree you're going into. There's also a really great Markdown tutorial here, which takes even less time, and I recommend doing it so that Markdown starts to become second language to you when you're writing Jupyter notebooks. And one more reason why you should learn about Markdown is because it's ubiquitous. You'd be surprised where Markdown is used. For example, readme files.md stands for Markdown. On GitHub are Markdown files. Also, Reddit uses Markdown. So if you're going to make a post to Reddit, you can use Markdown syntax in order to mark up your Reddit post. Okay, I am not going to go through all of the details of Markdown here. Please read through all of this information about headers and paragraphs, formatting text, lists, specifically unordered list and ordered list. Nested lists are lists within list, and you can mix the ordering unordered and ordered. Links are very important, including images. Some HTML is required for images in order to resize them, but it's very simple to do. And remember, since if you're going to view L3-2 on your own Jupyter Notebook server, then you can double click any of these cells and you can see how that Markdown is generated. So essentially you have the backend solution behind all of these code cells available to you if you're running this locally. In Notebook Viewer, you can't do this, but you can do this if you're running it locally. And tables are important. Okay, moving on to what is LaTeX. LaTeX, sometimes pronounced LaTeX, is a markup language to typeset documents, and most specifically, it's used in the mathematics community. So you can write full Word documents or documents similar to Word in LaTeX, but mostly people would do this perhaps if they're going to write a manuscript or write a book, or perhaps write some document that contains a lot of math formulas, or things like that. Another example is I wrote my dissertation, my PhD dissertation in LaTeX, and it was much, much faster and easier to edit than writing it in Word, because you can set links that are dynamically generated and everything is written like a programmer would think, whereas Word, you spend a lot of time looking for things in the menus, and you spend a lot of time with your hand on the mouse, which is slow. In LaTeX, you can spend a lot of time with your hands on the keyboard, which is faster. So I'm only going to cover very, very basic LaTeX, just enough to typeset some of the equations that we might use in Computer Science 215, but I highly encourage you to read more about LaTeX and even try writing some of your documents in LaTeX. I wrote my resume and my CV in LaTeX, which you can see online. If you're interested in getting the source files behind those two files, let me know. I'm happy to share those with you. LaTeX is a really great tool to have in your toolbox. Okay, so in a Markdown cell, we can write LaTeX code by entering math mode. And we enter math mode with either a single $sign or a double $sign. The single $sign will give us inline LaTeX, and a double $sign will give us math LaTeX. So block LaTeX. So for example, suppose this is my Markdown code. The word pi in LaTeX, pi looks more mathy. Now, if I were to actually render this, so let's look at the code. So this here is surrounded by ticks. So this is actually non-executable code represented as code, whereas without the ticks, this is going to be actual Markdown code that is executed. So pi looks more mathy. So do you see how it became a little bit more scriptier, a little bit more angular? Okay, so now if I were to do this with a double $sign, then the word pi would be centered on its own line. So it becomes a block rather than being inline. So now you know how to enter math mode and exit math mode, $sign, or double $sign, double $sign. So let's learn some basic functionality. In this class, you will likely be subscripting and superscripting text. So to subscript, we use underscore, and then LaTeX uses curly braces to group text together. So everything in the curly braces will be a subscript. So we have x sub I plus 1, the caret symbol to raise it to a superscript. Special characters are named, and you access their special character by name with a backslash. So earlier we were just using pi, but if we have a slash pi, this is the named special character pi, and it would render actually as pi. So if we look at this code here, enter math mode /pi for special character pi and math mode. And you can see how that is rendered right here. Another example is a nice multiplication operator with an x, a time symbol, instead of an asterisk. Fractions, so here's the syntax for a fraction, which can give you nicely typeset fractions with numerators and denominators on their own line instead of in line next to each other. A few other things, square root, summations, these are all really great to know, and if you ever need something else, quick Google search will help you out, and Share LaTeX is a great online community to learn more of the basics through tutorials and examples and forums. One last thing that sometimes hangs me up, it may hang you up too, is sometimes you actually do want a $sign, not to enter math mode. So you'll need to escape the $sign purpose of entering math mode with a /$sign. This is very similar to escaping, new line characters and tabs, etc. Okay, let's move on to L3-3, which is on plotting. This is a really fun lesson. Okay, so in this lesson, we're going to learn how to generate basic two-dimensional plots using a Python module called Matplotlib. Now, Matplotlib is included in the Anaconda 3 Python distribution, so you don't need to download anything extra. We're going to use Matplotlib to visualize some of our results that we're going to get, not just in our data analytics and our data science context, but also in some of the more data structures context we're going to work in, such as plotting the work done by sorting routines. We can do this very easily in Python using Matplotlib, and the plots can be embedded directly in our Jupyter notebooks. So no need to write our code, have a separate document describing the code, and then maybe have an Excel spreadsheet where we plot the results. We can combine it all in one with Jupyter Notebook. One thing I do want to point out is there are several plotting libraries or visualization packages available from Python. Matplotlib I chose for a few reasons. One is it is the most documented and the most widely used, and it is integrated very well with the data analytics infrastructure. I'm not saying it is the best, but for those three reasons, we're going to use Matplotlib in the class. Some other ones to look at include Plotly and GraphViz. Those are two other great visualization packages to look at, and Chaco as well. Okay, so when we want to work with Matplotlib, we have three options. The first option is through the PyPlot module, which is a non-object-oriented state machine environment, and it is the most quick and dirty way to get a plot generated. This is the approach that we're going to use most frequently, and I'll show you an example of this shortly. The second is a hybrid between PyPlot, state machine environment, and object-oriented programming. We'll do this sometimes when we need to access some objects like a figure or an axis directly to make changes that we can't get from the standard PyPlot interface. And the last one is a purely object-oriented interface. This is useful for embedding Matplotlib plots in GUI applications when you really need to keep track of memory and all of your references. We won't be using option number 3 in this class, but if you were to perhaps take one of your assignments or maybe your final project to a production phase, then you would want to explore option number 3. Okay, so let's get started plotting in Jupyter Notebook. So first, we'll have a code cell, and we need to use this magic command called matplotlib inline. So this tells Jupyter Notebook, don't generate these plots in separate windows. Instead, embed these plots in our Jupyter Notebook in line with our text output. Next, we need to gain access to the PyPlot module from Matplotlib by importing it. It's typically imported as plot, PLT. If you look at any of the examples online, you will see that PLT is used most frequently. So I recommend staying with convention and always importing matplotlib.pyplot as PLT. Okay, so with any plot, we need to have any two-dimensional plot, we need to have an x value, set of x values that are mapped to a set of y values. So my x values here are very simple. I'm going to generate 100 numbers, 0 through 99 inclusive, and I'm going to generate a second list called squares. This is going to be my y value that each x value is going to map to. And I built this using a list comprehension. So I'm going to square each number in x, and that is going to be my y list called squares. And I want to note that your x and y lists, in this case x and squares, need to be of the exact same length. And now I will call the plot function of the plot interface plotting x to squares, and I'll run this. And here is my plot output in line, which is really neat, really cool. So one thing to note is this output here. So plot returns a list of the objects associated with the current plot. Right now I'm not saving them, I don't need to, but in the future I might need a reference to this line 2D object here in order to maybe change it or keep track of it in some way. Now, here are the parts of the Matplotlib figure. So there's an outermost figure which contains one or more axes, and an axes object contains a two-dimensional x-axis and a y-axis, and then on the axes object, this canvas, there's a 2D lines object here. So this comes back to the object-oriented interface that we don't need to be too concerned with, but there will be times where we may want to, set the different tick labels on the x-axis, and we may need access to that axis object. So something good to keep in mind here is the object hierarchy or the object structure underlying the Matplotlib figure. So the next examples go through different types of plots and add in some kind of bells and whistles. So here I add an X label, so X values, you see that shows up down here, a Y label up here, and something that's really cool, another reason why we learn LaTeX, is Matplotlib has support for LaTeX. So I want to have a really nice typeset X squared in my Y label, so I enter math mode with X raised to the power of 2, and you can see on my Y-axis here, I get really nicely typeset X squared. So a few other things you might want to keep in mind is you can add, of course, labels, you can add a legend, you can change these tick locations, you can change the tick labels, you can add 2 Y-axes, you could add one over here, you could add 2 X-axes, one over here. There's a lot that can be done. Most of the time, these simple aspects that I've shown you so far will work for what we need to do. But if you want to do something cool, definitely do a Google search and hopefully you can find what you're looking for. There's a lot of documentation out there for Matplotlib. Okay, so I'm going to skip over the next examples. They walk through adding multiple lines to a plot and different line styles, so dashes and dots. Bar plots, these are really great if you're going to do histograms. Here there are X bars, air bars on the bars, histograms, and scatter plots. We can encode a lot of information with a scatter plot. Essentially, we can encode an XY position. The color of the dot could mean something, as well as the width of the dot. So scatter plots are pretty powerful. We can also have multiple axes objects on a figure using the subplot command. And here is an example of doing this as well. So with that, I'm going to wrap up week 3 lesson notes. Be sure to go back through these slowly and work through each example. And I'm not going to work any specific practice problems for week 3 because there's a lot embedded here. So I'm going to jump ahead and work on week 3 assignment, which is micro assignment 2, writing your own Jupyter notebook.